So let's take what we've learned about parts of speech tagging and named entity recognition and try it out through a practical lesson. We'll start with importing the packages we need. Once we've done that, we can move on to loading our dataset. For this lesson, we'll be using a dataset of BBC News articles. So we can load this in as BBC data and then use pd.readcsv bbcnews.csv. Let's take a look at what this data looks like with BBC data.head. So you can see we have a column for the index, we have the title of the article, the publication of the news article, some links and a description of the article. We can also run bbcdata.info and we can see we have 1,000 entries, so 1,000 rows and no non-null values. It's going to be interesting to see what kinds of parts of speech come out and what named entities can be brought out of these news articles. For now, we're just interested in working with the titles of each of the news articles, so let's pull these out separately. We'll create our titles and then create this as a pandas data frame just of the column titles from our BBC data. Let's check that's worked with titles.head. Perfect, so we can now see we've got a data frame of just one column of the title of the news articles. The next step is to clean up these titles. Because we've covered this in the last lesson, we're just going to quickly run through this, but feel free to pause if you want to take a look at the code again. So we're going to take our titles and convert them into lowercase, remove our stop words, remove any punctuation, tokenize and lemmatize the text. Let's check our processing with titles.head. Great, so you can now see we've got a column called tokens clean lemmatized, which contains the title, but it's been cleaned up, lemmatized and tokenized. Let's unpack the tokens clean lemmatized column into one single list. We'll also do it with the raw text. If you notice when we did our tokenization, we computed tokens on the raw title that hasn't been cleaned up, and we also did it for our clean tokens. So let's create our tokens raw list, which will be from our tokens raw column, and our tokens clean list, from our tokens that have been cleaned and lemmatized. We can then compare how these different methods work across our raw tokens that haven't been cleaned up against our clean tokens. Now we're ready to get started with some parts of speech tagging. The first thing we need to do is initialize the spaCy model. So we'll use NLP and then use spaCy.load and specify the model we want to use. We then want to create a spaCy document from our tokens raw list to see how the parts of speech tagging runs over our raw tokens. We'll use the NLP function and then use the join token to join our tokens together with a space in the middle, to make sure it's in the right format to create our spaCy document. We then create a new data frame where we want to place our parts of speech tags. So we'll create our POSDF, initialize it as a pandas data frame with the column headings token and POS tag. Let's now create a for loop to take each token and get its associated POS tag. This will run through each of the tokens in the spaCy document, take the text of that token, so just the token itself, and the associated POS tag, and place them into our POSDF. So we run for token in spaCydoc, and then we take our token, which is our token.text, and our POS tag, which is token.pos underscore. The next thing we'll want to do is create a token frequency count, so counting up the number of times each token appears in the documents and its associated POS tag. So we create POSDF counts, and we create this using POSDF.groupBy, and we're grouping by the token column and the POS tag. We then take the size of this group, so the number of rows in the group, and reset our index. We then sort our values by the counts and set it to ascending equals false. When we print this out, we can see the most commonly occurring tokens. And you can quickly tell that because we've done this on the raw data that hasn't been cleaned up, it's just given us a load of mess, really. So there's lots of punctuation and mostly stop words in the most common tokens in this raw data set. However, we can still pull out points of interest by looking at specific POS tags. So let's get started by looking at the most common nouns in our dataset. We'll use POSDF counts and then filter this to where the POS tag equals noun, and we'll just take the top 10. So you can see here our most common nouns in the dataset, the first being war that appears 35 times, followed by the word year at 14 times. Let's do the same with the verbs and see the most common verbs in our data. So here again you can see words like says, found, win, and if you remember this is a news data set, it gives you quite a nice overview of what kind of things are being discussed and what kind of topics are coming up in this news data just from this simple analysis. Again, we can do this also looking at adjectives, so we can see the words new, Russian, final are also coming up. Next, we'll move on to named entity recognition. But feel free to also pause this video and try doing some POS tagging on the cleaned up tokens and compare the difference between the two. So to get our NER tags, it's very similar to how we get our POS tags. We're going to initialize a data frame that we want to hold the tokens and their associated NER tags. And we'll call it NERDF. We'll create it as a pandas data frame with the column headings token and NER tag. We'll then run a for loop to get the entity labels for our tokens. So for token in spacydoc.ents, if pd.isNA token.label is false, we'll append to our NERDF the token text, so the token itself, and the token label, which is the NER tag. This is essentially saying that if there is an associated label with this token, append this to our NERDF as a new row. Let's check this has worked by running nerdf.head. Great, so we can see some tokens have been pulled out, such as Liz Truss, UK, Russian, 70 years and 70 seconds. Let's now look to see our most common named entities that appear in the dataset. We'll create our NERDF counts and use the nerdf.groupby. We'll group by the token and the NER tag, take the size, reset the index, and sort the values in descending order. So we can see here that Ukraine was the most commonly occurring named entity in this dataset, followed by England, the UK, and the US. So again, this is starting to give us some insight about what's contained within our data. Let's have a look at the most popular people in our dataset. We want to subset our NERDF counts, where the NER tag equals person, and we'll just take the top 10. So we can see all kinds of names coming up here, and again it's indicative of what the news was covering at the time. In this lesson, we've covered parts of speech tagging and named entity recognition as a way to delve into your data, understand what's in there, and start to do a little bit of analysis. Let's now move on to the next section of the course, where we're looking at the exciting topic of sentiment analysis.